Bruh. Welcome. Welcome everyone. Wednesday stream. Oh. First of all, sorry I didn't upload the VOD for Monday stream because I realized that I inadvertently had my desktop sound on during the initial initial 5 minutes, and the end result is that you can hear the teaser trailer, the audio for the teaser trailer of the new Monkey Island video game that has been announced, which is, I should know better to listen to music or watch YouTube while I'm waiting for a stream to start. Hi, MedX. Yeah, I should have noticed that. I honestly just, I saw the trailer and then the end result is that I immediately click play. No, I never code roleplay or GTA. Sorry. The category is game development, but I don't do game development. The only time I did game development was at uni, and it was a Tetris clone, and I sucked at it. Which is why I don't do game development. Yeah, on Monday on Monday I did a couple of things over the new project that I've been working on, which is a music player written in Rust for the GNOME desktop environment, and I've been like tweaking on and on some interesting features. Actually, last night I coded up an interesting feature. It was unexpected. I expected it to take a little bit more time than what it did, and instead I started off like midnight, and by 1:45 I had something that was decent enough to demo. So that was an interesting thing to do. Honestly, I didn't expect that to happen. It's always interesting. It's something that I actually noticed. I noticed with Rust that I've reached the point where I can sketch out some code on my pen and paper notebook, and then try basically just rewrite it in Builder, and it tends to work. I mean, the compiler still shouted at me a couple of times, but the overall gist of the implementation actually worked, which was unexpected. That usually does not happen until after a while, until after I've become a little bit more proficient with the language. So that was surprising. I didn't expect that to happen that quickly. I mean, I'm saying that quickly. I've been looking at Rust on and off and on for about 6 years now, so. And it's, yeah, again, this is the third project I started writing in Rust and started maintaining in Rust, which is, yeah. I'm still very much new at this. I hope I'm not writing C code in Rust too much. I mean, it's the yeah, it's the pitfall for a lot of C programmers like me. We end up writing C code in every other language we end up using. I've seen people write C code in Python, C code in Perl, Ruby, JavaScript. It's the typical pitfall. And of course, writing C code in Rust is not entirely alien from the language perspective, except that if you try to be clever with it, the compiler will descend upon you and will spank you until you give up and you write idiomatic code. So let's try and see. Yeah, I guess it's a little bit of demo. It's fine now. It's a good thing to show off. So this is not exactly the thing that I wrote last night and I showed on Twitter at 2 in the morning. Hi, Rednov. I started tweaking it a little bit again this morning because I realized it was way too slow. But yeah. Now, of course, I have an unused import. That's fine. Yeah. I was timing the duration of a bunch of stuff there. So yeah, the basic stuff. I'm running oh yeah, the other thing that changed. I've been running I've upgraded yesterday from GNOME 41 and Fedora 35 to GNOME 42 and Fedora 36. So now my entire desktop is in dark mode constantly. So. Oh, COVID and broken PC. Oh, I'm so sorry about that. Yeah, I've had COVID as well, like 2 weeks ago, so I know how that feels like. And I still have a couple of a coda to that. Cough, cough. But yeah, what I've done last night was this. If I add a folder, and of course it opens on the other side of the screen because there's a bug in GTK / GNOME shell, and the saving the Windows state is completely borked. But yeah, if I add a folder to Amberol, yeah. So what I've done is this: the window, the appearance of the window, the style sheet gets modified using the dominant color of the cover art. Wherever it's possible. This is computed at once, and it's stored inside the song metadata as well. So when we don't have to recompute that all the time. And another thing that I did change for this particular bit is storing the cover art directly inside the song metadata. Not on disk, of course. I'm loading stuff from disk, but whenever we load all the songs, we immediately store the cover art, so we don't have to reload it or re-upload it to the GPU. It's stored already inside the song object, which is not something that happened, that they used to happen when I outline how Amberol is written last Friday. But yeah, that was a simple change. You may notice that the text color also changes to reflect the fact that the background is dark or light. So we do a little bit of color detection and decide which color to use for the text to compensate for the fact that the background is now different. Yeah, it's a nifty little feature that Cassidy just pointed out during on Twitter, like this weekend. And basically, it's something that a lot of music players for mobile do these days, which is kind of what Amberol like aspires to be, kind of a very simple local music player that is modeled fairly specifically on Muin from 15 years ago and the iOS music player on my phone. But yeah, this is pretty much like the result of a couple of hours of work last night and about an hour today. So let's see how I implemented this, because it's actually pretty interesting the way it works. So let's close this, and we go into our song object, which is the core data type for Amberol. So back last Friday or Monday, I honestly don't remember now, we stored the cover art as a bytes buffer instead of storing it. Basically, we just took the bytes buffer out of the tag object when we parse the metadata of the file on disk, and then we extract the bytes buffer there. The bytes buffer is usually encoded in as a PNG or a JPEG. There's also support for TIFFs, but honestly, who does that? We go through all the pictures that are stored there. If there's more than one, usually the first one is the cover, so we care about that only. And if we find it, yeah, in the past we used to just store the bytes buffer, and then whenever we change the song in the queue, once we loaded the song, we would take that byte buffer and then let me find it. Yeah, we took the current byte buffer of the current song, and then we turned it into a GTK texture. A GTK texture is a GTK4 object. It is the representation of some pixel buffer that is immutable post construction. So you construct it and it's there, cannot be changed. It's not like a GDK pixbuff. So it's not like a true mutable pixel buffer. It's an immutable pixel buffer. And it's immutable because GTK will try very hard to take that pixel buffer and upload it to your GPU as fast as possible and as soon as possible. And if the pixel buffer were mutable, that would be a problem, because you would not be able, you would have to keep a copy of the pixel buffer in system memory and in GPU memory. And you don't want to do that. You honestly want to remove it from system memory as fast as possible, so you have enough room for other stuff. And the way that it works is that instead of being able to access the pixel buffer, you have to download it back from the GPU, which can be very expensive. Cough, cough. So what we do now instead is we literally just take the byte buffer, turn it into a GDK texture, and then store the texture directly inside our song object. This is useful because we don't have to keep a byte buffer, an encoded byte buffer around, and we don't have to decode it every time we change the song. So that cost is gone. We do it once, and we do it only when loading it. And I measured it earlier, like today, and I realized that it takes about 2 milliseconds to turn a byte buffer that is encoded in as a JPEG or a PNG file into a GDK texture. GDK4 is super fast at doing that. So honestly, I mean, you're paying 2 millisecond price, but even if you do it just once, it's fine. After that, we look at the contents of the cover art and we extract the dominant color there. So the way I did it last night was I literally kept the byte buffer across operations here, and then I decoded it locally using the image crate in Rust, which is fine. If you do a debug build, it's gonna be slow. It's gonna take like 200 milliseconds, but it's honestly, it's something that it's not really necessary. We are already decoding it here. Doing another decode pass is pointless, honestly. Is this code open source? Hi, Mimi. And yeah, the code is open source. Is on GitLab. .gnome.org is on the my namespace. So let me find the repository there. There it is. Yep, it's GPL v3. So if people want to use it, that's absolutely fine. Yeah, we load the dominant color and we take that coupler and we store it also on the song data, the song metadata object, basically. How it's done, it's actually fairly cool. So there is a crate called Color Thief on crates.io that does exactly that. It will go through the pixels in a pixel buffer and will determine the dominant colors, or at the very least the color palette of an image. It will extract the more relevant colors according to a certain threshold and blah blah blah, and it's very, very useful. Oh, thank you. Thank you. Yeah, I'll try to be super chill. But yeah, what it does is literally get the palette, in this case we get the 6 most relevant colors from the image data, and then get palette from Color Thief will return a vector of RGB values, like packed together. We apply a map here to turn them into GDK RGBA. GDK RGBA is just a color representation for GDK. it uses 4 channels like RGBA, and they are normalized values between 0 and 1. Cough, cough. So we take whatever get palette returns us, which is U8, and we normalize the values into a GDK RGBA, and then we return the first color. So the way this is implemented, let me see if I can find you the crate. Okay. Right. So Color Thief uses what is it? Yeah. I honestly don't remember the algorithm that it uses for that. Yeah, this is the demo. But yeah, Color Thief originally was a JavaScript implementation. So Color Thief RS is the reimplementation in Rust. It's pretty fast. It's about 150 times faster than JavaScript. There are other like palette extractors. One of them is palette extract, which is what I was using before. Most of them use the exact same algorithm, the median cut quantization or the modified one. But yeah, basically what it does is it will subdivide the image that you pass to it into buckets, and then we'll find the we'll try to sort the pixels inside the bucket so that it's the most relevant one are the first ones, and then we'll move to another bucket and do the same, and then we'll basically just figure out which colors just pop up at the very top. Yeah, it's exactly the same. Color Thief uses exactly the same algorithm, because the original Color Thief Swift, which is written in Swift, and then was ported to JavaScript, and then it was ported to Rust. So I'm using exactly the same thing. The main difference is that palette extract is a little bit slower than Color Thief, I noticed. On the same dataset, Color Thief will take about 10-15 milliseconds tops. Same quality, same number of colors. Quality is the sampling size, so it will skip like, I don't know, 5 pixels, 10 pixels. Whereas palette extract will take a little bit more than that. It can all take up to 50 to 100 milliseconds, depending on the quality. So it's actually a little bit more expensive. I honestly don't know why. I haven't actually like profiled that much this code base. I just started looking around for which crate was the fastest. Rust has an incredible number of packages. Yes, it does. It's something that I actually noticed the other day. So I wanted to start writing a music player in Rust in 2015, and back then there were no crates whatsoever that dealt with extracting the metadata for music files in different formats. So not just MP3s, but also like OGS or whatever. And I noticed that basically there was nothing there. So I had to write my own bindings for taglib, which is a C library that a lot of music players on Linux use. And I wrote that. I wrote the bindings for that, and for a while, it was basically the only way to extract metadata from all the music files. Cut to 2022, I started using taglib for Amberol, but I realized that there are a lot more crates these days for extracting music metadata out of files, and one of them is what I use now, which is Lofty. I'm not used to this. I'm a C developer. C developers are really okay. I'm gonna use this this framework because it provides me with basically everything. If I don't have something, I will either have to copy and paste it from somewhere else or write it myself. And now I am confronted with the fact that in Rust, it's very likely that there is something already available for me to use. And maybe there are like multiple variants that I can choose. So I was actually shocked about that. And it's not something that I'm used to. I'm still getting used to it. Is functional programming in Rust complicated for someone who uses C? Not really. It's not a lot of functional stuff. I started writing like a C programmer would probably use a for loop here and then just collect stuff like manually here. Instead, in Rust, use map. I don't think it's a huge leap. It's not like higher order functions, like higher order types or anything. It's not a huge leap, like huge step or a huge change in how you perceive the language. You are iterating over the contents of a vector. Instead of using a for loop, you can use a function and you pass a callback to the function. Yeah. We do that in C as well. Oh, Alatier, Yeah, I think it's not a huge leap for the style of programming that GNOME developers actually use. We use callbacks all the times, which are basically closures. We have to do a lot of this stuff manually because, of course, we don't have any help from the compiler or the language to capture like variables or data across the closure line. So we have to create our own structures and hold our data there. But other than that, I've written libraries that iterate over vectors or container types using callbacks. It's not a huge leap, to be fair. Or at least it's not a huge leap for me. Let's qualify it. Yeah, so the original code for low dominant color took a bytes buffer here, which contained the raw cover art like encoded in whatever format it came in. I used the image crate to turn it to load from memory and put it inside a pixel buffer, and then the pixel buffer would be interpreted by palette extract or color thief or whatever, and stuff like that. Instead of doing that, earlier today I decided I already have the decoded data in memory. It's not uploaded to the GPU yet because I just loaded the song data here, and it doesn't exist on associated to a widget, so it's not on the rendering pipeline yet. So instead of doing that, let's download the texture data, which means copying it from the internal representation inside the GDK texture, and put it inside a vector, a buffer here, and then we feed the buffer to get palette. This operation takes about 20 milliseconds instead of taking the original like 200 to 300 milliseconds that the image grade would take, which is still not like free, but at the very least it's not super expensive. The only other way to do it would be to decode this stuff inside GDK pixbuff, and then take the GDK pixbuff and upload its content inside the GDK texture, and use the same pixbuff to get the palette for the color palette out of the pixel data. It will take exactly the same amount of time, probably a little bit more, because the decoding in GDK pixbuff is not like super fast. It's still mediated through a bunch of layers inside GDK pixbuff, whereas GDK texture will try and be as fast as like physically possible. It will call directly into libping or libjpeg or libtiff, whatever. So it's actually a little bit faster because there are fewer intermediate layers in between. But yeah. So now that we have the dominant color, what are we going to do with it? It's gonna be fun. So what we do with it is we created, so when we created a window instance for our main player, we also, where is it? Where are you? It's probably in the constructor. No, where are you? Here. We create a CSS provider object when creating our window, and then we attach it to the display. When we are setting up the state, yep, we attach the CSS provider to the display, and we give it like a user priority, so an application priority. It overrides anything the application sets. Cough cough. And then whenever we change the song or we update the queue, we take the dominant color out of the cover. We determine if the color is dark or not. And if the color is dark, we use, depending on whether the color is dark or not, we determine the foreground color that we're going to use against the background color, which is the cover, the dominant one from the cover. These constants are taken from libadwaita, so they are coded here. I could, in theory, extract them from the style context myself. It's, yeah, I went for the hacky way for this. I didn't want to do it like the clean way. Again, I wrote this stuff at 1 in the morning. Then we define two name colors, one background color and one foreground color here, using the two colors that we just found. And then we load that little bit of CSS like fragment into the CSS provider, and we add a class to the main window. If the song does not have a cover, which means doesn't have a dominant color for it, then we remove the CSS class. And the CSS class is defined here. So whenever your window has the main window class, like whenever this matches, this CSS selector matches, we change the background color and the color using the named color that we just defined. And then we use a little bit of transition to animate the change. So every time these two colors here change, which means we just reloaded them inside the CSS provider, then the background color and the color of the window will change. This is super, super hackish. It's, yeah. There are a couple of applications that do this. Yeah. I wouldn't recommend people just copy it, honestly. I would never recommend people do this. It's actually pretty terrible. I mean, I love it because it's such a terrible way of doing things. But yeah, until we have a proper recoloring API for libadwaita and GTK, then this is kind of an approximation of how you do recoloring of your main window. As far as I know, GNOME text editor also does this. The contrast app does this. So it's not like I'm breaking new ground here at all. Come on. But yeah, it's kind of a hack. Let's call things the way they should be called. It's kind of a kludge. It's funny, but it's kind of a kludge. Epiphany 2? Yeah, I kind of guessed that. I mean, there are many ways of doing this. GTK does not have CSS variables, and the only thing you can do is named colors. So for instance, if I wanted to, so right now this works with solid colors only. So add a folder. This works with solid colors only. So it takes a single color here, that is the dominant color, and that's it. In theory, what I would like to do is taking like 3 colors, the 3 most relevant colors from the palette, and then create some sort of gradient that like fades between these colors, so the background is a little bit less uniform and a little bit more nice. Cough, cough. But yeah, if I want to do that, I would need to have multiple background color, multiple named colors, like background color 1, background color 2, and background color 3, and then have a rule here that does like a linear gradient between them, which is always fun. But the amount of colors is, of course, determined by the cover art. So let's imagine a cover art for a track that is just black and white. It will give you 2 colors, not 3 colors, because there are only 2 colors there. So the end result is that if there are no colors here, I would have to make someone up and fill out the rest. Wonders how many dominant colors material you extract. I have no idea, honestly. So the way other music players do this, like on the mobile space and in some other places, is the trivial one. Let's take the cover art. Let's subsample it like until it's 16 by 16 pixels, and then just blow it up using a blur, using a convolution filter. It's not even a blur at that point. At that point, you have a background that is kind of reminiscent of the cover, but not really, but yeah. But the way that interesting music players do this is actually to use the dominant colors, but then arrange them in a way that is not like a simple, like solid background. They will figure out, there are a bunch of places where they figure out ways to position those colors so that the overall effect looks a lot like a blur, but it's not a blur. Also because blurring is expensive, regardless, whereas extracting the colors and then just blending them is usually a lot less expensive. It doesn't require readbacks and doesn't require like computing Gaussian curves on the GPU, which is always fun. So a lot of people have started doing this instead of going with the I'm not gonna say the trivial route, but generally speaking, the most accessible, most obvious one, which is trying to blow up the a blurred version of the cover art. Also because the cover art it depends on the position of the cover art, right? So if the cover art is sitting in the middle, if you're blurring everything and you create a blurred version of it, then you are essentially just showing the edges of the cover anyway. So if the cover is, let's assume that you have a cover with like a rectangle, you have a square cover, and in the center you have like a lot of colors there, but then they're surrounded by a black, like massive border there. If you blur it, you are just going to blur a lot of black and not much in, even if it sits at the center. And then if it sits at the center, it gets covered by the actual cover, at which point you're not showing anything. You just blurred. You just done a lot of work to show nothing of the actual cover. So there's no real point in doing that. But yeah, this is what I do at like 1 in the morning instead of sleeping. But it was an interesting journey of discovery. Let's just say that, because it's interesting to see what the Rust ecosystem is providing. So there is a lot of functionality there that people can actually use now. Even non-trivial stuff, like niche stuff. But also, it's kind of interesting to notice how it gets easier to deal with some functionality over time when the language starts to make sense, which is the interesting threshold that a lot of languages have, a lot of people have to overcome, and a lot of languages try to ease people into. Like, the curve when you reach the point where you understand that you know nothing, but you know that you know nothing. So yeah, like for instance, this bit here is what drove me insane today for about half an hour, because I couldn't understand how to get a vector initialized. This is the C developer in me that was completely baffled by this. So I have a vector here, which is fine, and then I used to do this. Because of course a new vector will have a length of 0, but I want a new vector to be initialized to be able to contain the entire size of the texture data. And you go on the Rust standard documentation, standard library documentation, and you realize, and you read that the default API to do that is with capacity. With capacity, will initialize the vector to be able to hold a bunch of data without having to resize. And then you realize that is not enough, because you pass this buffer to the download method of the GDK texture, and the download method will say, okay, how big is the buffer? And the buffer is 0, because it doesn't contain anything. And you have to go into a little bit of voyage there, and to realize that you don't want with capacity, you want the resize method here, because the resize will work like calloc in C. So it will not only allocate the size, reserve the size, but will also set the contents there, and we want to initialize everything to 0. And just like that, just like magic, you do this and you pass it to the download method, and everything works out. But in order to figure that out, you have to go a little bit mental first, because as a C developer, I'm used to allocating a bunch of data, and then that data is there. So, okay, I allocated a chunk of memory. Of course, now I pass it to a function that expects that chunk of memory and will write into it, and the function will write into it. Of course, it will assume that everything is all right, because if something is wrong, then you will get segmentation fault, or every single file in your file system will turn into encodings of capybaras taking a bath. It's absolutely fine. But in reality, no, you not only want that, you not only want a proper language will check that you're actually passing enough memory to write into. It will not just start randomly writing at random positions just because I'm gonna pass you a memory buffer. The API will say, bet. Yeah, it's important to note that although the return vector has capacity specified, the vector will have a 0 length. And guess what? Texture download. What does texture download check? That the length is not 0. Because in theory, you could pass a statically allocated pixel buffer here because of reasons. So you have to have a length specified, and yeah, instead we're passing a dynamically allocated one because we have no idea how big it is. So we have to allocate that. And in order to do that, we have to pass this. But yeah, that's... Ironically, it's not the functional programming aspects of Rust that are tripping me up more often. It's the, this is not C. You cannot do whatever the fuck you want. You have to write code that doesn't blow up in your face. And the compiler, and we'll check on that. Compiler and libraries will check on that. So the end result is that, yeah, if you want to use texture download, remember to resize the buffer and not just allocate it with a capacity. And that will work out. Though, strictly speaking, people should not use this at all. They should be using this only in very specific circumstances. Only if you know that you just loaded up a memory texture. Otherwise, it's going to be expensive. It might be incredibly expensive. So, yeah. What I wanted to do today, I wanted to add yeah, I wanted to add the ability to open a file directly from Amberol, so that people can use it to like right-click on a song file and then open with Amberol, for instance. And to do that, there are a couple of things there to be done, and it's gonna be fun. So right. So in order to do that, what are we going to do? GTK, glib, and GIO here. So by default, a GTK application or a G application will not handle the command line at all. It will leave it to you entirely. So there, it has a couple of flags to deal with that, like handles the command line, yeah. It also has a couple of, if you specify that it handles the command line, you have two like entry points. One is for the local command line, you parse it before the application will try to contact the will try to go on the session bus and see, is there another application with the same name running, and then if there is, it will take the command lines that survive the local parsing and it will send them over to the currently running instance of the application, and it will terminate immediately on the new application that you just launched. But that is the complex thing to do. This is a GUI media music player. It doesn't have a command line. It does not need a command line. There is no point in me doing so. So all we care about really is the open flag, which is the flag that is used to tell G application that if there are whatever follows the binary name, so whatever arguments it get passed to the application, they are going to be files. So take the list of files and try and open them. Which means that we have to change the flags here from no application flags to application handles open. Does not need this here. Okay. And then for handles open, we are going to need to override not just activate, but also where are you? Open. So GIO application has multiple entry points. Not only has the activate one, the activate is your it's tag, you're it. It's you're the running instance. Do whatever you do whenever a new instance gets opened. So typically open the main window of your application, but you can receive multiple activation over the course of your lifetime as an application. So every time a user launches the application, what you actually do is you're emitting the activate signal on the currently running application. So at that point, if your application supports multiple windows, you open a new window. That's it. There's nothing magic into it. It's kind of a change, a pretty big change compared to how GTK applications used to be written in the past. So in the past, you initialize the toolkit and then you set up your UI and then you spun the main loop using GTK main. And then whenever you close the window, you would stop the main loop from running. It's a very imperative, very linear way of programming GUI applications. You set up, you initialize, you set up your UI, spin the loop, terminate the loop, return, done. With the advent of G-application, which is required for a bunch of other things like dbus activation or what else? Being able to determine if there is another instance running, so uniqueness of an application, or what's it called? Being able to start an application whenever in response to another event or anything else similar to that. You're not really following the same pattern anymore. You cannot follow the same pattern anymore. You have to have a wrapper around it, so to speak. You create an application and then you respond to events coming to the application, just like you would respond to events coming to a window of your application. So it's less an imperative linear setup, execute, terminate kind of step that is more common in low-level toolkits like SDL or inside games or similar other old-style toolkits. It's more event-driven, exactly like the rest of GTK. So one of the entry points, activate. Another entry point, open. Open is practically exactly like the same, like activate, but instead of creating the window and be done with it, You have to create the window, and then you have to do something with the files that you get passed. So you have to opt into this behavior here. But yeah, we have an activate here, and then we'll have an open, and then we'll have an application. This is the what's it called? This is the Rust wrapper, and this is the actual type, GObject type around it. And then we'll have the files. I honestly, why am I looking at the C API when I'm using Rust? Force of habit. So I need to look at the application X. There should be an open. Yep, you'll get this. Oh, sorry. A reference of arrays and an int here. A reference to a slice of files and an hint. It's gonna be fun trying to figure out how to debug this, because opening yeah. Yeah, we'll see what happens. So we do pretty much the same thing as we do in the activate. So if there is an application window, then use it. Otherwise, we create one. And we present it. But also, we will have to add each file inside the files slice into the queue. And luckily, we have the API to do that. Except that it's not public, because of course it isn't. So let's extract that particular bit of API. So and add file. And what it does is literally does this. And that's it. So in theory, you could also do self and we are not going to change this because it's a lot. yeah, we're not gonna change this one. We're gonna still call the internal API. I mean, in theory, we could also make this public and then modify the application here instead of giving us we take the files here and we slice them into a GIO list store and then we pass it. Yeah, it's not gonna happen. For F in files, when file through. And now let's see how loudly the Rust compiler will start shouting at me. Pretty quickly. Yeah, I did a stupid thing here. And yeah, I'll have to add this. I have no idea why the yeah, I have no idea why it needs to borrow it. This is a real value. Why should it borrow it? Oh yeah, I'm upcasting that. Why am I upcasting that? Let's see if this works instead. Yeah, I'm upcasting it because it expects that. So yeah. Otherwise, the two branches of the if let are not going to be exactly the same. So we can do downcast. And, so we have to cast it down. Yeah, and of course. We don't care about that. And we do a move here. Why am I doing this here? So I'm moving stuff, which is not good. Probably I need to... Let me double check. I need a reference, probably. See if this works out though. Yeah. And I constantly forget about that. Yeah, I'm borrowing stuff, but and then it goes. Probably I need those as a reference. No. Okay. Oh, downcast ref. Yes. I was on the right track. I constantly forget. So this is another difference between like the habits of a C developer with regards to Rust. The casting is not only verified at runtime, but also is subject to the same rules as the rest of the language. So downcasting moves memory. Yeah. That's what I was gonna do anyway. But thank you. And right, because I know it's gonna be always correct. Let me remove this because it's not useful anymore. Yeah, it's I'm so used to casts between types to be a free operation that the impact of this change, this language like construct, is it's hard to overcome at the point where I am in terms to the language itself. The idea that casting is not just casting, is moving memory from one place to another, which means that you have to take care about references and stuff like that, is the point where I'm still at the point where it feels a little bit alien and counterintuitive, even though it's completely justified. You are literally moving memory from to one place to another. Cough. So the end result is exactly that. You cannot just cast stuff. Okay. So this one is going to be a little bit weird to test because I don't have access to the binary build. So maybe I can do something like this. No, I have to go on to terminal. No, wait. This one should give me... Or not, wait. I should have one now. Yep. Yeah, I'm pretty sure Builder has a way for me to pass a command line. So in theory, I could like build preferences, probably add some more stuff there, but or I could have access a bunch of extra args. Oh, okay, yeah. Thank you. Thank you, Alatira, yeah. Yeah, there are definitely ways of doing that, but I'm so used to some tools that it's Stockholm syndrome now. And it's not. it, you get into the habit, and then the habit just breaks you. Another reason why I actually decided to switch to Color Thief instead of and remove the image grade was that they both added about 50 dependencies there, which is it's the downside of the ability to have access to a ton of modules to implement a bunch of functionality there. You end up with a pretty deep dependency chain. I'm already like building 205 crates. But yeah, it's pretty interesting to to realize how much we take for granted. It's not as bad as like Node or whatever, where you're basically just cloning GitHub, but it's still pretty deep. Misses app development. Oh, yeah. I know the feeling. I know exactly the feeling. This is probably the hypest I'm gonna get with this application, because once it's doing what this application doesn't do much, and once it does all that I need it for, all that I'm asking for, it's gonna be just maintenance until the next application. Which is the reason why a lot of people just go completely mental and decide to add email or chat or plugins to applications. It's because then you can get the dopamine rush of a new feature. Which is, I mean, this is my opinion on this. It's not something that it's shared, like it's my hot take on this. It's my controversial opinion. It's fine to stop working on an application or a project. It's fine. Nothing will happen. It's fine. You can just start something new. You don't need to constantly do stuff on something. It's fine. It really is. Okay, so let's try music. Yeah, of course, it's not installed. Yeah, I don't want to install though. But at the very least, it's working now. Let's see. I don't have polarity here, so I'll have to where did you say the I guess it was somewhere here. Let's see what happens there. It's called X run arts. Okay. Oh, it's in the manifest, yeah. Okay. So flatback, manifest. Yeah, test instance there. Yeah, but I need to pass a set of files there, and it's gonna be fun. So yeah, testing that is gonna be so, because another way of doing this, well, it's not another way of doing this, it's the way then that will work out after that. Basically we need to add to the desktop file here the list of MIME types that this application can open. So let's see if I can find yeah, something like this. In theory, I should not be doing this. Yeah. In theory, I should be getting the list of MIME types that are supported by GStreamer and generate that at compile time. There is even a tutorial there. Developer, documentation. So, tutorial, no, it's a guideline, container guidelines, integrating GNOME. MIME types, here. So, yeah, if your application can open the specific MIME types, you need to add the desktop no in the desktop file. You add the MIME type there. And then you need to tweak the exec line there. So the exec line, it's going to be this. We can open URIs, not files. Exec. So it's actually slightly different there. Yeah, we don't need anything else because the MIME types are already there. We don't need to install new ones. We don't have special we don't have special URIs, the URI schemes or anything. But yeah, and at that point, if you have like let me see if I can get it there. Yeah, I don't have it installed here, of course, because I'm running off of GNOME Builder. So if I had it installed, I could go inside my music directory, and then I could decide to open it with another application here, and Amberol would appear here if I had it installed in my system, which will happen pretty soon, actually, because thanks to Jakub, thanks to GMAC, I now have an actual application icon. Let's see. Here we are. This is the development version, but as soon as it's not development anymore, it's going to be this. Yeah, the design team came through. As usual, I commit a crime against design, and the design team comes through and fixes it for me, and I'm so glad. I mean, I'm terrible that way, but yeah, I'm so glad that there are people with actual taste in the GNOME design team. Yeah. So one thing that this will have to cope with is the fact that Amberol is a sandbox application, and that means that it cannot have access to the entirety of the file system. It will have to have access to specific location in the file system, and everything else has to go through the portal API. So it can deal with that. But it is a problem. It is a problem for another time. Yeah, even this little bit of like coding is it's inching us closer to the end of this application. Of course, it's not the end. There are like a ton more. There are a ton of things that need to happen as well. So since I sometime I cosplay as an adult, I opened a bunch of issues here in the project issue tracker, and there are a couple of things that I want to implement before doing a proper like stable release. I'll probably do an unstable version somewhere, but for the time being it's fine. This one is so that the GStreamer developers will stop throwing up every time I talk about this application, because it's the way it's designed is terrible. The internals are terrible, to be honest. But this is kind of an outline of what I'm of how an application is usually designed in Rust and GStreamer, using message passing so that the internal core loop that is the player state does not manipulate anything inside the same thread. It will just send a message to the outer application, and the application itself will then respond to that from outside the GStreamer thread. It's mostly rejigging the internals of the application. It will require some pain, mostly to bring a bunch of stuff that currently exists deep inside an object has to be brought outside into the outer layer of the application itself. So the concept is the main application creates both ends of a channel, a communication channel that can cross the thread barrier. The sender is passed to the player object, and the player object updates the state internally and does a bunch of other things. And then when it has to notify the application, the UI, that something has to change, the player will send a message. A message is just an enumeration field with some payload attached to it, or not. It's absolutely fine if it doesn't have any payload whatsoever. And then the application outside will receive that message and do something on the window or the state or everything else. Right now, how it happens is when the player changes something, it will call a method on some state object, and the state object will update some GObject property, and the window outside the UI part is connected using property bindings or the notify signal directly to the state object. The main problem of that is that all the signaling mechanism is synchronous and happens in the same thread in which it is emitted. We know that the thread is the same because we told GStreamer, hey, please emit all your signals inside this this thread. But strictly speaking, that's not a great thing to assume, and also complicates the lifetime management of the various bits of the code base. So the proper way of doing this is just sending messages and then having something on the outside catching those messages. I need to add shuffle support. I have a couple of ideas on how to make shuffle. Basically just pre-compute the queue, and then if I apply a shuffle parameter, then I pre-compute all the shuffled like positions and then just go through them. That is the easiest way of doing this. And then I want to do a couple of reviews of the UI style and the UI states. Oh, hi, Georges. How are you? You had a stream yesterday about Bosun. How did it go? Oh man, yeah. Didn't you have a stream? Or I'm confusing a scream. A stream. Or is it today or tomorrow? Yeah, I think I saw an announcement, but was I dreaming? I mean, I'm pretty sure I saw an announcement for a stream. Oh, yeah. Oh, God. Thank you for confirming I'm not going completely mad. Oh, boson inception. Streamception. Okay. Yeah, I need to rebase this and then do a couple of other things there, but it's gonna be fine. But yeah, apart from a couple of things that they are like blocking the 0.2 milestone, they are mostly cosmetic in terms of internals and UI. The last missing feature is the shuffle. Oh, more work needed. I'm to be absolutely honest, I think it's already great, but hey, if you're adding more features, that's absolutely fine. It's a great app, honestly. It's the GNOME app renaissance with a lot of people writing useful applications, and they're me, but it's great to have proper applications, honestly. It feels almost like we've finally reached a point where, okay, the platform is good enough. We can figure out what to do next, but first people have to write a lot of applications. So we can wait until people do that. We are not trying to catch up anymore. We are in a position where stuff will happen if we just let it happen. And yeah, like Boson and all the little applications that are fitting up FlatHub, they're great. They're not little because they're pointless. They're little because it's good to have applications that do very few things. Not because it's the Unix philosophy, but it's because we don't need massive applications that require tons of people to work on them. Mostly because those like huge applications end up being either made or acquired by large corporations, and it's not great. Yeah, it reminds me of GNOME 2 and the Mono days, indeed. Hey, Yalter. Yeah, those were the days. But I mean, we had a ton of those like cycles. We had a cycle with Python, we had a cycle with Vala, we had a cycle with Mono. Now we're having a cycle with Rust. But the important thing is that we are getting these applications to the user pretty quickly and unmediated by random downstreams. So as soon as the application is available, it's available for everyone, and that's great. You don't have to wait 6 months to get it inside the distribution or whatever. The platform got out of my way. Yes. That is exactly what I felt while writing this little application. The platform got out of my way. I was able to concentrate on building the UI and then just figuring out how to make it work with Rust and whatever. I was actually learning the language. No, I was not learning the language, but I was learning how to integrate a bunch of things there. But the platform itself was not my problem at all. My problem was that I suck at Rust. It's not my problem was not how do I put the UI together, how do I make it work, how do I set up all my dependencies, how do I do a bunch of other things. I started literally from download builder, create a template, add a bunch of stuff, and there. It was great. I've never had this experience with GNOME in nearly 20 years. So that's great. So I'm actually pretty happy with how Amberol turned out, and how everything worked out. Now I just need to make it like nice and not suck completely. So, and yeah, as soon as I have a couple of other things done, I'll push it to FlatHub so that people can shout at me and say that my application coding skills suck and my application designing skills suck and whatever. And it's gonna be fun. So yeah, as I said, one of the things that I wanted to do was redefining the UI states there, because yeah, we're completely winging it. There's a lot of stuff that happens and I have no idea why it happens. It's not that I don't have any idea why it happens, but it's not defined, so every time I change something, something breaks or doesn't do whatever I expect it to. So, but if I start doing that and then I change it to do message passing, I will need to redo a lot of this stuff anyway. So the message passing is going to be boring and a lot of trial and error. It's not even going to be like good content, because I cannot do it incrementally. There's too much stuff going on. So it's going to be like a chunker of a merge request anyway. So let's go back. Yeah, I mean, the recoloring stuff worked out fine. Again, it's pretty hacky in a way, and I'm pretty sure there are a bunch of like nasty side effects going on. Like, I'm not entirely sure that the behavior is correct in every single use case. Let's avoid the MCA strike. Sorry. Like, for instance, this is getting black here. Getting a black dominant here. In theory, could be this orangey here, though. It's a struggle. But yeah, the color here is correct, for instance. Same here. This one is a little bit iffy. Same here. It's kind of I think it's kind of struggling because it could be white, black, or this bluish here. But yeah. Who knows? It's not like I control the entire thing, so I have to trust that the implementation of this algorithm is actually correct. Also, I think I want to take this and put it inside a card. Actually, no. So the playlist here, the situation with the playlist is not great. Right now is inside a revealer. So if I let's demo it. It's easier to understand if I demo it. So this is the minimum size of this application here. You can already see the fact that it's like this when it starts. It's weird. It's because there is a revealer here and the sizing is meh. So if I add a song, a single song, like this, it's a single song. There's no need to have a queue here. so that's fine. The cue only appears if I add another song. And here we go. Which is, again, it's fine. It's not great, but it's fine. But the sizing is all kind of meh, and I don't like it particularly. Additionally, this is a list view, which means that I cannot really style this like I would a list box. So the first child is gonna have the rounded corners, and the last child is gonna have the rounded corners as well. So it's not gonna be stylable like that, because the rows here are dynamic, they are like filled up as they go, and the content is recycled. So let's assume I filled up like with 100 songs here. The actual widgets would be 20 probably, and then the contents would be recycled through the list model that populates it. That would imply that this row here will always be the first, even if we are scrolled halfway through. So that's not gonna happen. So we'll have to figure out styling of the queue in a different way. But yeah, what I would really like actually is a way to have this playlist here always, like, if not always available, but always present, and then probably have a button here. You press the button and the window resizes to show the playlist, and then you press it again and the window resizes and when it goes away. But I need to check how the animation is done there. I can probably use the animation API inside libadwaita to resize the window if I know the size, but it's also gonna be kind of iffy. Oh yeah, I also need a way to delete songs from the queue, like pressing a button here, or it appears on hover or whatever, so I can delete. Because right now the list view here is single click activation, so you click on a row and the song starts playing instantaneously. If I added a button here, I would need to switch to non single click in activation to avoid like confusing the entire thing, the entire state machine. So that's gonna be an interesting thing to figure out. But yeah. Okay, dokes. So this is gonna be a short stream. I'm not gonna keep you here for a long time, so don't worry about that. I'm gonna do another stream on Friday, and on Friday I'm probably gonna be like knee deep into the guts of the application, but I don't want to spend too much time doing boring stuff. I also have a few other things that I want to do on stream. One is probably another Cairo snapshot, because I did the Cairo snapshot and then I got COVID. I think the two things are related in some way. But anyway, I did a Cairo snapshot, and turns out there were a bunch of regressions, and also the build system was kind of broken. Like if you build with Meson, the build system will be broken. If you there were a couple of other regressions here and there, but mostly caused by something that happened in the past year and a half, so nothing to do with me, like precisely. And the other thing is I still don't have access to the the web server with all the Cairo snapshots. I asked the free desktop sysadmins. I haven't heard back from them, so I allowed to start poking people. But I honestly want to do another Cairo snapshot. But before I do that, I need to figure out how to drop the auto tools from the build. I started already a merge request, but the merge request has had some nitpicking, so I need to address that. So I might do another Cairo snapshot on stream, or at the very least prepare for a Cairo snapshot on stream, because I've noticed that a lot of people have enjoyed watching me suffering, which is great. Apparently. COVID gave me Cairo. Yeah, sadly, yes. But yeah, so yeah, we'll see on Friday how I'm if I'm struggling too much with Amberol, I'll switch to something else. Otherwise, I'll just power through the boring bits of the development of Amberol. Well, the refactoring of Amberol. Yeah. So I hope you had fun. I hope I explained how I did the experiments at 2 a.m. If you have any questions about the development of this application, just feel free to like contact me on Twitter or like on Discourse or whatever. Now time for the usual outro. If you enjoy watching me working on the GNOME platform, writing applications, documentation, or writing your favorite toolkit, GTK, and libadwaita, the library for GNOME, then why not subscribe to my YouTube channel? I upload the VODs of my streams usually the day after the stream happens, unless there are some mysterious accident with the audio on my stream. Otherwise, you can join me live. You can watch me struggle like in real time, with a minimal delay actually. But yeah, just follow me on Twitch, twitch.tv/ebassi, and you will see me writing documentation, application code, toolkit code, or I can just chat about the GNOME development and the GNOME community, because apparently that's what I do. For everyone here, thank you very much for following along, and have a great rest of the day, great rest of your Wednesday, and I shall see you all on Friday for a new stream. Bye.